Hi everyone, here's a calculus question that we should be able to solve fairly easily because there's some key terms and relationships that stick out. So we've got a derivative and it says for what values of x is f of x increasing. So let's take note that we're actually given the derivative, this is f prime of x, but we want to know something about the original function in terms of it increasing or decreasing. In this case, just where it's increasing. So let's think back to what we know about the derivative and how it relates to the original. We know that a positive derivative means a positive slope of the tangent, so the function is going up like this, which we call increasing. So let's just write that out. We know if f of x is greater than 0 or positive, then f of x is increasing. And that's the relationship we need to focus on. The key term here, if you're seeing this question on a test, is f of x increasing. That should be a red flag going off that we know straight to go to the derivative and find where the derivative is positive. So how do we find where this big mess of a derivative is positive? Well, start with the points that make it either 0 or undefined, which is really nice that it is factored right now. So I'm going to draw a number line. We can see that any value of x that makes any of these brackets, so x minus 7, x plus 5, x minus 2, any of those brackets that become 0 means that's an x-intercept of the derivative, right? It means the derivative will be 0, so we want to put those parts on our number line, those points. Any value of x that makes the bottom of the derivative 0 means the derivative is undefined there. We also want to put those on the number line. So it should be relatively easy to see. We know 7 is going to be, so we've got 7. We know negative 5 makes the second bracket 0. We know 2 makes a bracket 0. We know 3 makes a bracket 0. I'll maybe give us a bit more room there. So 2 makes this bracket 0. Then 3 makes the bottom bracket 0, so it'll make the whole derivative undefined. And then negative 4 makes the other one. Makes the whole derivative undefined. Now all you have to do is test the gaps in between all of these numbers. Basically, if we put a number greater than 7 in, it's going to do something to the derivative in terms of making it positive or negative, and which will kind of hit this gap. And then when we move to the other side of 7 and put a different value in the derivative, it's going to change sign. So let me show you what I mean. So let's just label what we've got. These are our x values. We want to test the sign only. We don't care about the actual value, just the sign of f prime of x. So I'm going to start on the far right here. If I put a number greater than 7 in, I'm going to run through here in green what all of the signs of my brackets will be. A number for x greater than 7. So this is going to be positive, 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 positive. Right? Because any number greater than 7 is going to make every single bracket positive. Positive divided by a positive is a positive. So the first derivative is positive when x is greater than 7. And that's what we're looking for, right? We're looking for what values of x cause the derivative to be 0. Now let's look between 3 and 7. Okay? What changes? Well, let's pick the number 4. Now all of a sudden, if we put 4 into this first bracket, it's going to be negative. 4 minus 7 is a negative. Everything else is still going to be positive. So we'll have a negative on top. Negative times a positive is a negative. Positive on the bottom, and we get a negative. So see what I mean, how the sign changed here, and I knew it would because x minus 7 is one of the brackets of the power of 1. Now let's go between 2 and 3. Okay, what changes? Again, let's put 2.5 in. That's going to change this x minus 3 bracket. This is now going to become negative. How do we know that? Put 2.5 in. 2.5 minus 3 is negative. So we've now got a negative on top, negative on the bottom, and it's going back to positive. Something between negative 4 and 2, plug in 0 everywhere. That's just a number in the gap. What's going to happen now? All the signs will stay the same except for this one will now go x minus 2. This will now become negative. Again, 0 minus 2 is going to be negative. That makes the top become positive again, divided by a negative, is a negative. What happens between -4 and -5? Well, what you would think is that this bottom bracket, the x plus 4 squared, would now become negative because we're putting, say, -4.5 in. But notice the square. This is key. That bracket's being squared, so no matter what is inside the bracket, it's always going to be positive. If you square a negative, it's positive. If you square a positive, it's positive. So nothing changes when you jump from -4, from one side of -4 to the other side. We still get a positive divided by a negative, which is a negative. And then lastly, if you do move left of -5 and put -1,000,000 in, all the signs will stay the same except for this one, the x plus 5. That will now become negative. So you've got 3 negatives on top, which is a negative, negative on the bottom, negative divided by negative is positive. So our final answer, we want all the intervals where f prime of x is positive, right? We said that. That's where the function's increasing. So here, here, and here. So we've got x less than -5. We've got x between 2 and 3. And we've got x greater than 7. These are the intervals that will cause this function to be increasing. F of x is increasing on these intervals here based on the fact that the derivative is positive in those intervals. So again, see the word increasing, you got to think immediately that that is, where's the derivative positive? Find the x values that make the derivative 0 or undefined. Put those x values on your number line. Test the gaps in between those numbers in your first derivative and find where it's positive for increasing or negative for decreasing. Hopefully this is helpful. A lot of calculus questions are just like this. They'll give you increasing or decreasing. You have to find the intervals. Follow those steps and you should be just fine. Thanks very much, and we hope to see you at our prep seminars coming up.